Hi guys. So today I want to talk to you about dynamic arrays. Now, dynamic arrays are basically an array. You can put a list in an array list we're talking about in the book. By the way, this is the book 7.2.1. Now, this allows you to put as many items in a list. They all get stuffed into an array. Only when you run out of space in the array, you can't do it anymore. This means you have to anticipate how big your data is actually going to be and make sure your array is bigger. Now, so you could have plenty of memory left over, but your program can crash out because you don't have enough space. So the idea is, a long time ago, they invented something called a dynamic array. Now, the basic theme of the dynamic array is when you, let's see, here is it. Okay, and it's right here. In that case, as the user continues to add elements to the list, all the reserve capacity, that's the spaces you haven't used in the underlying array, will eventually be exhausted. So in this case, the class just grabs a larger array from the system, copies everything from the small array into the new array, and then starts over from that, and gives up the older array. And so, this is all from the book. Okay, so we allocate a new array B, we copy it, and okay, so why do you need, I think you don't even need to see the code for this, so I'm going to, so this is basically the same array stuff, except when you're inserting, or adding in this case, you check if the array is full, and then you resize to, in this case, twice. Now what's interesting about this is it's got a very interesting average case for speed. The idea is that as you put things in the array, the array, when you do that copy operation, that's going to be a really slow push. So this has a little problem in that most of the pushes will be real, or most of the addings, right? Most of the items inserted will be really fast, whether it's an array or a stack or whatever. But that last item you push in is going to be sort of slow while it copies everything. But the trick is that while the copies are slow, they don't happen very often. Okay. Now, here they go through this whole cyber dollar type thing. But let's talk about the idea of, and here is some math, and I'm going to go back to the spreadsheet and start talking about, and you can read that in the book. You don't need me to read the book to you. But I'm going to talk to you about how I approach this. So, the idea is for an array of size n. So for an array of size, and let's make it 2 to the n minus 1. Okay, much copying? Well, so you have it essentially, it's a full thing. So let's say we start with an array of size 1, and each time, oh, that's your previous lecture uploading, and that's the upload failing. Okay, I'll get that to work later. Let me finish this lecture first. Okay, how much copying do we need to do? Well, okay. So, the idea is we copied the 1. We did 1 copy to get to the 2. We did 2 copies to get to the 4. 4 copies to get to the size 8. 8. And we add, and basically you can add those all up till, so we go ... and that eventually we did 2 to the n minus, oops, n minus 1. That's not what I wanted to happen, but okay. So that's how all the copies we did. So the idea is, what does this all add up to? 1 plus 2 plus 4 plus 8. Well, in binary, this number is 1, 1, 1, 1, 1, 1, 1, 1, 1. Right? All once. Right? 1 plus 2 is the 1, the 2, the 4, the 8, and so on. And with n minus 1, which is equal to the n minus 1. Right? That's what happens. Okay? That's what gives you n minus 1 ones in binary, basically. Now, so, basically, the amount of copying we do is proportional to the size of the data. Haha! And it's between, in this case, the size and twice the size. Why is it between the size and twice the size? Well, this is a full thing. Okay, once we do one more, we'll add one more 1. So it's between 2 to the n minus 1 and 2 to the n, and 2 times 2 to the n minus 1. Between twice that, do that. 2 to the n copy. The n minus 1 copy. 2 to the n copy. Okay, so it's between this and twice that. But regardless, it's proportional. So, basically, the dynamic array costs twice what a non-dynamic array costs. And for not having to worry about running out of space, except when you run out of all the space in your memory, that's really worth it.